Solve the inequality and express the answer in interval notation and in set builder notation. Let's first notice that this is a linear inequality because the variables are all raised to the positive 1 power, and if there are fractions, the variables are located in the top of the fraction, not the bottom. When we have a linear inequality, we're basically going to use the same process to solve it as we would if it were a linear equation, which means that we're going to get the variable terms to one side, the constant terms to the other side, and then we usually divide to isolate the x. Sometimes we would multiply, but most of the time it's divide. And one thing here that we want to add into our process is that since we do have an inequality and not an equation, if we were to multiply or divide in this last step by a negative quantity, that would cause the direction of the inequality to switch. So let's get going here, again, using the same process as we would if it were a linear equation. I usually prefer to start by clearing the fractions, and we can do that by multiplying both sides by the LCD. Now, in an inequality, we can only do this if our LCD is a constant value. In this case, it is. The least common denominator is 6, and so we can multiply both sides of an inequality by a constant. And let's just make a quick note here that we cannot multiply both sides of an inequality by a variable. So if our LCD contained an x, we would not be able to multiply both sides by that. And that's because if the LCD contains a variable, we wouldn't know whether or not to switch the direction of the sign. A variable quantity can take on positive or negative values. If you multiply an inequality by a positive, it doesn't switch the sign. If you multiply an inequality by a negative, it does. And so we cannot multiply both sides by a variable because we don't know whether or not it would switch the sign. So only if our LCD is a constant value are we allowed to multiply both sides by the LCD and clear the fractions. So let's begin by multiplying on the left-hand side. We have 6 over 1 times x over 3. This LCD is a positive value, so it does not switch the direction of the sign. And then we multiply 6 by 2 to get 12. And then our LCD times this last term is 6 over 1 times x over 6. And we can see that this LCD is the smallest value that all of the denominators divide evenly into. And in this first product, 3 goes into 6 2 times. In this last product over here, the 6's just cancel out entirely. So our first product becomes 2 times x, or just 2x, greater than 12 plus this second product, everything canceled out except for just the x. So now it's time to get the variable terms to one side. Let's subtract x from both sides so that we end up with 2x minus x, which is just x on the left, is greater than 12. And as a matter of fact, we are now done with the isolating x part. Now we're being asked to write the solution in both interval notation and in set builder notation. So let's put our solution on a number line just for clarity's sake, and we want all the x values that are strictly greater than but not equal to 12. So that means we would be shading to the right of the 12 with a parens here, not including the 12. The interval notation is going to look very much like the graph on a number line. We start with the smallest value and we finish with the largest value in the solution set. We do not include the 12, so we're going to write a parenthesis around the 12, and we never include infinity, so again a parenthesis around that. So this is our solution written in interval notation. We also need to express it in set builder notation. And for set builder notation, we always start with the same template. We have a curly bracket, which stands for the set of all x's. This vertical bar means such that we leave some space in here for our criteria that needs to be met, and then we close the set with another curly bracket. Now the criteria that needs to be set in here, this is the landing spot for the inequality that we came up with a moment ago. And so we simply put that inequality into the criteria field, and that completes our set builder notation.